So today we discussed regarding another category of the power converter, that is cyclo-converter. So what is cyclo-converter? Already we discussed all the category of the converters, that is AC to DC, that is rectifier, DC to AC, that is inverter, then DC to AC, that is inverter, and DC to DC, that is chopper. And today discuss regarding AC to AC converters, that is nothing but the cyclo-converters. So what are the articles contain that particular subject chapter, that is introduction, then types, then principle, single phase cyclo-converter, three phase cyclo-converter we have to discuss. Then definition: a device which converts input power at one frequency to the output power at different frequency with one stage conversion. AC to AC conversions developed in 1930 in Germany. The uses particularly SCRs or thyristors, and these are force commutated in nature. So cyclo-converter actual definition is cyclo-converter, that is CCV, or a cyclo-converter converts a constant voltage, constant frequency AC waveforms to another AC waveforms of a lower frequency by synthesizing the output waveforms from segments of the AC supply without an intermediate DC link. Drop 1993 PP 2241, 2243 and Lender 1993 P181. Now what are the types of cyclo-converters are there? First one is step-up cyclo-converters. Here F0 is greater than Fs, means F0 means the output voltage and Fs means the supply voltage. So cyclo-converter in which the output frequency which will be more than the supply frequency. Second one is step down cyclo-converters, means F0 is less than Fs, means output frequency is less than the supply frequency. Single phase to single phase, another category, that is single phase to single phase cyclo-converter. Sometimes it is also known as single stage to single stage cyclo-converters. Fourth category, that is a midpoint cyclo-converter. Fifth category, that is bridge type cyclo-converter. Sixth category, that is three phase cyclo-converters. First of all comes to the step up cyclo-converters. The step up cyclo-converters or step up CCV, as the name suggests, this type of CCV provide output frequency greater than the input frequency, but it is not widely used since it not have much practice applications. June 14, 2001. Then step down cyclo-converters. The step down cyclo-converter forced commutation and results in an output with a frequency lower than that of input frequency F0. The output frequency F0 is less than the supply frequency Fs. The step down cyclo-converter is physically commutated and the output frequency is limited to a value that is a fraction. Then single phase cyclo-converter, these are also of two categories. First one is step up cyclo-converter, second one is step down cyclo-converter. So step up cyclo-converter low frequency to high frequency, and step down cyclo-converter here that these are high frequency to low frequency converters. Step up cyclo-converters, low to high frequency converter, midpoint cyclo-converter, bridge type cyclo-converters. Here today discussed regarding the midpoint cyclo-converter. Here two diagrams are drawn here, that is this one is your figure number 1, this one is figure number 2. The figure 1 shows the circuit diagram of a midpoint cyclo-converter. So from the beginning it is clear that this cyclo-converter operates both in step up mode and also in step down modes. Let us come to the study about that particular circuit diagram. Then we have to study regarding the output voltage and output current waveforms drawn here. So come to the circuit diagram. The circuit diagram actually comprises of a transformer whose primary winding is connected directly to the supply voltage Vs, and the secondary winding is provided a mid-tap portion, that is the point is nothing but O, and the terminals of the secondary winding of the transformer, that is terminal A and terminal B. So in terminal A, two number of thyristors are connected anti-parallel with each other, that is P1 and N1. The terminal A connected with two number of or one pair of thyristors, that is P1 and N1. Both P1 and N1 are oppositely directed or anti-parallel or inverse connection with each other. Then come to the another pair, that is P2N2. So the P2N2 is connected to the another terminal B. Here these two thyristors are also connected anti-parallel, inverse parallel or oppositely directed with each other. These two thyristors are P2 and N2. These are also connected with oppositely directed with each other. Then the load is connected at the midpoint of the secondary winding of the transformer and across the two number of bridge circuit formed by four number of the thyristor P1, P2, N1, N2. And these are the terminals A and B. O is the midpoint. So VAO is the voltage between the terminal AO, and VBO is the voltage between terminal B and O, VBO, B and O. And the load voltage here V0 marked here, I0 is the load current, Vs is the supply voltage. So this is all about the circuit diagram of the midpoint cycloconverters. So see that here out of the four number of the thyristors, P1, P2 are the positive group of the thyristors, and N1, N2 are forms the negative group of the thyristors, because P1 and P2 conducts only during positive half cycle period, and N1, N2 are conducts during negative half cycle period. Hence P1, P2 belongs to the positive groups and N1, N2 belongs to the negative groups. Then the supply voltage Vs is obviously AC voltage in nature, alternating in nature, that amounts to be Vs is equal to Vm sin omega t. Then come to the second diagram, that is the output voltage V0 and output current I0 waveforms are marked here. Here the alternative conduction of the thyristor pair P1, P2, N1, N2 are marked simultaneously one after another. Then come to the operation, how this particular cycloconverter, how it converts the fixed input frequency into variable output frequencies. So as this cycloconverter converts AC to AC conversion, hence this type of converter is to be a one stage or single stage cycloconverters. Then come to the operation. This operation of that particular cycloconverter study in two different cases. Let us come to the case number 1. In case number 1 condition, let us assuming that initially one pair of thyristors start conducts at a time in such a way that one from positive group and another from negative group, or in other way we can say one comes from the odd numbering of the thyristors and other forms the even number of the thyristors, or in other way also you can say one comes from the upper half of the bridge circuit and another comes from the lower half of the bridge circuit. So let us assuming that we are giving the get pulses to the thyristor P1 and N2. During this condition there is no get pulses given to P2 and N1 thyristors. So in that case the current now start flowing in a particular path. Suppose during thyristor P1 in on condition, the path of the current will be VOA, P1, then load, then VOA. That is upper half of the secondary winding hyphen P1 hyphen load hyphen upper half of the secondary winding of the transformer. Similarly, at that particular instant, suppose at the instant of t omega t1, then the thyristor P1 which will be commutates and N2 will be start conducting. So during N2 start conduction period, the path of the current also like this, that is lower half of the primary winding, then load, then N2, then lower half of the secondary winding of the transformer. So in this way, the current now circulate by conducting P1 and N2 simultaneously from one after another. So during P1 on condition, it also drives the load. So the path of the current will be VOA hyphen P1 hyphen load hyphen VOA. That is, in other ways, we can write the upper half of the primary winding, secondary winding, then P1, then a load, then also upper half of the secondary winding of the transformer. And at a particular instant, that is suppose at the instant of omega T1, P1 commutates and N2 will be start conducting. So during N2 start conduction period, the path of the current will be upper half of the lower half of the secondary winding hyphen load hyphen N2 hyphen lower half of the secondary winding of the transformer. So in this way, it will circulate the current throughout the bridge circuit by receiving the supply from the secondary winding. But due to the transformer action, whenever primary winding gives some supply voltage, then some EMF induced at the secondary winding of the transformers. As the secondary winding is made taps, that's why in both half of the secondary winding transformer, it will develop some voltage. That is, EMF will be developed as well as upper half of the secondary winding, also in lower half of the secondary winding of the transformer. Then come to case number 2. Whenever at the instant of this process will be continued, when you reach at the instant of omega t is equal to pi region, both P1 and N2 are commutates on another pair of the thyristors P2N1 which will be start conducting. So now in case number 2 period, whenever P2 will be start conducting, the path of the current will be OB, P2, then load, then OB. In this way, the current now circulating through the P2 and developing a particular amount of the frequency. And whenever the P2 will be reached at this instant, that is immediately another omega t instant, then it is observed that P2 will be commutates and N1 start conducting. In that case, the load current now transfer from this thyristor to this thyristor, that is upper half of the primary winding, upper half of the secondary winding hyphen load hyphen N1 hyphen upper half of the primary winding. In other way, you can write upper half of the secondary winding, that is AO load, then N1, then hyphen AO. So in this way, the current also circulating by following that particular loops. And this process will repeat, that is due to the conduction of P2, that is due to the conduction period of N1, you are achieving that particular amount of the frequency. At this instant also you are getting another particular type of instant frequency, that is at the P2. Similarly N1, this is for P2, this is for N1. So in this way simultaneously it will continues by triggering and commutating P2 N1, P2 N1 one after another. Whenever the curve reaches at the instant of 2 pi region, then it is observed that the thyristor pair P2 and N1 which will be commutates and another pair of the thyristor, that is P1 and N2 again start conducting, and this process will be continued. So this portion shows one particular envelope, that is positive cycle period. In that case V0 will be positive and I0 will be positive. And in that case during N2 conduction period, V0 will be negative and I0 will be negative, and this is from the another envelope. So by closing these two, these form a particular loop. Similarly in this portion here, whenever P2 will be conduct, then supply voltage forms this particular envelope, and during N1 conduction period, the supply voltage forms another conduction period. So by closing this from pi to 2 pi region,